In this example, we're asked to verify that the rank of U times V transpose is less than or equal to 1 for these given U and V right here. Noticing, interestingly enough, that V is given in the abstract. It could be any vector whatsoever, but U is specified as -7, -5, and 4. So first of all, what does rank mean? What's the rank of a matrix? Well, if we have a matrix A, the rank of A is equal to the dimensions of the column space of A. So I'm sure that's super helpful. Here's what that means. The dimensions of the column space of A. It means if you have a matrix A, let's say, I'm just going to give one, a very specific one, 1, 0, 0, 0, 1, 0, 0, 0, 0, 2, 3, 0. Let's say that's what we have. Okay. Well, the column space is going to be the same thing. The number of dimensions in the column space is going to be the same thing as the number of pivot columns you have. There's a pivot column here, and there's a pivot column here. Well, why is that? Well, the column space is just how many dimensions can you cover with this matrix, or the columns of this matrix. And so if we think of this as an augmented matrix right here, then what this means right here, first of all, is that x1 equals 2, x2 equals 3. But x3, because we have a row of zeros, x3 is free, meaning you can choose any value you like for it at all. Well, what does that mean? Well, if I write down a vector here, we've got 2, 3, and then x3 right here. So the dimensions of the column space here is 2 because, let me break this up a little bit more. We have 2, 3, 0 plus x3 times 0, 0, 1. And this makes it a little clearer. So the reason that the dimension of the column space is 2 is because you need 2 vectors to define a basis for this space. You need this vector right here, 2, 3, 0, or some multiple of it. And you need this vector right here, 0, 0, 1, or some multiple of it, right, times x3. And if you have these 2 vectors, or any multiples that they're in, then you're able to cover the whole column space. And that column space needs 2 vectors, so the dimension of the column space is 2. If it was 3, then you'd need 3 vectors to do it. If it was 1, you'd need 1 vector, and so on and so forth. So that's what rank means. So now let's look at this and verify that apparently the rank is 1 or less, depending on what values A, B, and C take on. So first of all, we need to do the multiplication of U times V transpose. Well, U is -7, -5, 4. And we're going to multiply that by V transpose. Remember, V transpose means that all the rows become the columns and all the columns become the rows. So this goes like this. And this becomes A, B, C, written like this. And now, be very careful to do the matrix multiplication. Well, how does it work? You take this right here, the first column, you go, ooh, and you multiply that by each row on this matrix. So this becomes A times -7, or -7A, A times -5, or -5A, A times 4, or 4A. And now do the same thing for B on each one of these. So this becomes -7B, -5B, 4B, and then do C on each one. -7C, -5C, 4C. Now, row reduce this as much as you can. Notice that for each one of these, I can divide the entire top row by -7. I just get ABC. I can divide this whole row by -5. I get ABC. I can divide this whole row by 4. I get ABC. Well, then notice that I can subtract row 1 from row 2 and just get a row of zeros. And I can subtract row 1 from row 3 and get a row of zeros. So I have ABC, 0, 0, 0, 0, 0, 0. So how many pivot columns do I have? Well, boom, right there, assuming that A is not 0. If A was 0, well then this would just be a bunch of zeros, and this would be my pivot column. If this was 0, this would be a bunch of zeros, and this would be my pivot column. And finally, if all of these were 0, then I would have no pivot columns. And from here, I showed you the number of pivot columns gives you what the dimensions of your column space are, which is the same thing as rank. And we see here that if at least one of these are not 0, so if A, B, C are not all 0, so at least one of them is not 0, then the rank of U V transpose is equal to 1. If A equals B equals C equals 0, if they are all 0, then the rank of U V transpose is equal to 0. And now if you just look, if I'm either 1 or 0, then I'm less than or equal to 1. And there we go. So we have verified that for this U and this V, the rank of UV transpose is less than or equal to 1. And that is this example.